Let's make smart contracts even smarter. Today we're going to be building a smart contract which allows the swap of an NFT for HBAR or wrapped Bitcoin. But here's where things get more interesting. Using Chainlink's data feeds, we can provide accurate prices for crypto into our smart contract. This means we can swap the NFT for a fixed dollar price paid in crypto like Bitcoin or HBAR. Before you begin, make sure you head over to portal.hedera.com to create your own developer account. This will give you all of the testnet HBAR that you need to deploy your smart contracts. Now let's head over to the smart contract. What I'm going to do is I'm just going to give a quick overview as to the smart contract which I have at the moment. I've already written some code on it and we're going to be implementing some new code to facilitate the transaction between the Bitcoin and the NFT. But I'll do a quick overview of the code. So as you can see, we're importing some some contracts and interfaces from OpenZeppelin. We are also importing the Chainlink aggregator interface. This is very important for the Chainlink Oracle integration, as well as the Hedera precompile so that we can interact with the native Hedera token service using the EVM. In our smart contract, we're calling this constructor. So this constructor is doing a few things. First of all, it allows the user to set the price of the NFT in USDC, which is pegged to the US dollar. We're also setting the address of the USDC token, the address of the wrapped Bitcoin token. We don't need to set the address for HBAR because it doesn't actually have an address, it's the native token for the network. We are assigning the addresses of the Hedera token service tokens that we would have already created. And we're also wrapping them around the ERC20 interface. Now, despite them being a Hedera token and having all of the benefits of the Hedera native token service, we can actually use the ERC20 interface when it comes to transacting with them and interacting with them inside of smart contracts. So it's a nice feature that Hedera have, which allows the native tokens to be used almost as though they are ERC20 smart contracts. We're also hard coding in the address for the HBAR USD price feed, and of course we'll be adding the smart contract address to get the Bitcoin USD price feed as well, and then just the metadata over here, that's the metadata for the NFT. I've implemented some functions which allows us to get the HBAR price, convert USDC to HBAR, purchase with USDC, purchase with HBAR. We're not going to be looking into this code too much, rather we're going to be doing the code from scratch for the Bitcoin implementation. And I'm also going to quickly go over some of the Hedera token service precompile functions which we have as well. So we've got the ability to create an NFT, that's using the Hedera token service create non-fungible token function. And again, this is creating a native token via the smart contract service. And we're also minting the NFT. Now, the idea of having this mint function is it means that we can mint on the fly. So we can mint as soon as someone transacts, and we'll get into that functionality when we create the Bitcoin swap function. So now that we have that in mind, let's start writing the code so that we can buy with Bitcoin the NFT priced in the dollar. So the first thing that we need to do is we need to create a new price feed variable. In this case, it's not going to be for the HBAR USD, it's going to be for the Bitcoin USD pair. So let's change that name over here. And we're also going to want to initiate that or instantiate that in the constructor. So let's take that and we'll say this variable equals the aggregator v3 interface. And I'll give a bit of an explanation as to what this aggregator v3 interface is. So if we go over to this documentation over here, we can see that the aggregator v3 interface, which we've imported from this Chainlink contract library, the aggregator v3 interface is the interface of the smart contract which is deployed on the Hedera network, and that smart contract is the Chainlink Oracle, meaning it's able to get the data off chain and provide it to us in a trusted manner. So we are creating a contract which is really the data consumer. We're consuming the data that comes from the aggregator v3, and we are using this latest round data function within inside of the aggregator v3 smart contract, which allows us to get the relevant data. Now, this here in the documentation, they're using it for the Sepolia network, which is an Ethereum testnet. We're of course using the Hedera testnet, so I've gone over to this link. All of the links will be provided in the description, but we want the Bitcoin USDC contract address, and we're going to want to just pass that in when we are constructing it and instantiating this in our constructor here. So we've got the HBAR USDC address. Now we have the contracts address for the Bitcoin USDC, and now we can interact with this smart contract, this price feed Bitcoin USD smart contract when it comes to fetching that price. Let's make sure we add our semicolons over there, and we're good to continue. So the next function that we're going to do is we're going to get the latest Bitcoin price. And we can again have a look at the implementation over here. How does Chainlink do it? We're going to do it the same way. So I'm just going to copy and paste this code. You can have a look at the smart contracts if you want to see a deeper dive on what the actual aggregator v3 smart contract looks like, but I've already seen it. So obviously our smart contracts, we've called it internally price feed Bitcoin USD, and it also returns these other variables, or these other parameters. We don't need them, we only want the answer. Now the answer, it's going to give us the price of 1 Bitcoin in USD, but it's going to give it times by 10 to the power of 8, meaning it has 8 decimals. So obviously with EVM and Solidity smart contracts, you can't have decimals. So the way that we manage numbers that should have decimals is we just add loads of zeros onto it to allow that to be the decimal point. This is going to be important to consider when it comes to transferring this 8 decimal number with some other numbers, for example the USDC token which we have, which is 6 decimals, but we're getting a bit ahead of ourselves. Let's go into the next function, which is converting that USDC to the Bitcoin. Meaning, in the constructor, we said, okay, I want my NFT to be priced at 10 USDC, $10. We need to create a function which then goes, okay, you want $10 worth of Bitcoin? I know what 1 Bitcoin's worth in dollars. Now I need to scale that down into the relevant amount. And the first thing that we need to do is we need to get the price of 1 Bitcoin. So that's pretty straightforward. We can go, I think this returns that's the wrong function. So we get the int256, which is returned from this function, and we can pass it in here. So we want to say int256 Bitcoin price equals get latest Bitcoin price. Obviously you could put this code in here, you could do it however you want, but we're doing it this way. Then we're just going to make sure that the Bitcoin price actually is a real number, it's greater than 0. So let's just do a require statement, and we want to require that Bitcoin price is greater than 0. If not, throw an error saying invalid Bitcoin price. I'm going to put a semicolon there. Always remember your semicolons. Then what we want to do is we want to convert the price in USDC, which we set over here. So we set the price in USDC up here. We want to convert that so that we can identify how many Bitcoins do we need. Now, I'll be completely honest, there's a bit of maths involved in this. I'm not going to go into the maths, but really be conscious what decimals are the relevant tokens that you're using in your calculation. How many decimals do they have? It will affect what sort of multiplication that you need to do. I'm just going to copy the code which I have over here in our get latest, in our HBAR convert USDC to HBAR function, because the decimals are the same. So I'm going to copy and paste this. And the important thing to note is Bitcoin amount is going to equal the Bitcoin price. Now, this is the important thing, which will vary based on whether your token has 6 decimals or 8 decimals or 18 decimals. It's how much you multiply your price in USDC. In our case, we're multiplying it by 10 to the power of 10, and then we're dividing it by the Bitcoin price for 1 token. The reason why we're multiplying it by 10 to the power of 10 is because our Bitcoin amount is priced in 8 decimals, our USDC is priced in 6 decimals, and for that reason, we need to do it like this. Again, I'm not going to go into the maths, but I can do in the comments if you think it would be useful. The final thing, we just need to return this Bitcoin amount. And amazing. And so what this function's doing, just as a recap, this function is getting the internal state of the smart contract where we've set the price in USDC. We set that in the smart contract constructor. It's then converting that into Bitcoin by using the up-to-date Bitcoin price, which is coming from the Chainlink Data Feed. And that's this get latest Bitcoin price function. Awesome. So we've got some really good preparation in place so that we can now actually create the purchase with Bitcoin function. And what this is going to do, it will be triggered by the user who wants to purchase the NFT by sending the smart contract Bitcoin. So step one, we need to get the Bitcoin amount that we need. That's needed so we know what to take from the user's account. So let's get the Bitcoin amount. Now this is going to be a uint256 because we did this int256 to uint256 conversion. This is going to be a uint256 Bitcoin amount, and that's going to equal convert USDC to Bitcoin. Next step is to transfer that amount from the sender of this function, the person who's invoked the function, send that to the smart contract. In order to do that, we can use the ERC20 smart contract interface because we have a Bitcoin Hedera token service token. It's a native fungible token. But remember what we did up here is we wrapped it around the ERC20 interface, meaning we can use the smart contract functions of a typical ERC20 contract, like transfer from, to actually perform that transfer between peer-to-peer. So let's use that function. It's going to return a Boolean, which is our success, true or false. And that equals wrapped Bitcoin dot transfer from, and the transfer from address is the message.sender, and the transfer to address is the address of the smart contract, which is address this, and we're going to be transferring the amount of Bitcoin amount. Wrapped Bitcoin token is what I want. There we go. And again, I'm just going to double check my implementation, which I did down here. USDC token transfer from, yeah, that looks good. So let's check that it's true. Let's paste that in here. We're going to require that success is equal to true. If not, we can throw the error that Bitcoin transfer has failed. And now we can mint the NFT. So let's have a quick look at our mint NFT function. This necessitates that the create NFT function has already been called. However, assuming it has, we can call this mint NFT, which returns the serial. Now the serial is going to be useful when it comes to transferring the NFT because we need to know which serial of the NFT to transfer. So let's say we'll call this mint function over here. That doesn't take any arguments, but it does return the serial. And then, assuming that has happened correctly, we can now transfer that serial. Again, we're going to be using the ERC721 interface for this. So we've created in our create NFT function, we've created a non-fungible token. This is a native Hedera non-fungible token, but after we created it, we wrapped it in the ERC721 interface, and because we've done that, we can now treat this non-fungible token as though it's a ERC721 smart contract. Really useful for EVM developers who already have EVM code or are familiar with developing on the EVM. So let's call that. We're going to be using the NFT, again it's transfer from, and this takes the from address, the to address, and the token ID, where the token ID is the serial. So the from address is address this, the to address is going to be the message.sender, and the token ID, this is just the serial. Now I'm going to double check, so it looks like the serial needs to be a uint256. So what we need to do is we need to convert that serial into an int256. And that's going to be the serial. And then we need to convert that int256 into a uint256. There are better ways to do this, by the way. There are safe conversion libraries, and because this is a very controlled environment, I'm not going to bother with that. But if you're deploying into production, definitely use the safe transfer libraries as well. So that's now compiling well, and we've got everything that we need, which is really great. So we can actually now start testing our function and actually test the ability to retrieve this Bitcoin price from the smart contracts, from the Chainlink Oracle, and then actually swap the NFT. So let's get into deploying it. I'm just going to head over here into our deploy and run transaction section. Going to make sure that I've got my injected provider with my MetaMask. Just going to log in now. And let's load up the MetaMask. So I've already imported my Hedera accounts in here. If you haven't already, head over to the Hedera portal and import your private keys into your MetaMask. Then you can get access to all of your Hedera tokens inside of MetaMask. So let's get into deploying the smart contracts. The first thing that we need to pass in is the price in USDC, and the USDC token which I'm using, which is just a testnet token I created myself, it has 6 decimals. So if I want to say it's $10, then I need to make 10 with 6 zeros. The USDC address would be the same token which you're referring to here. Again, I created this beforehand, so I'm just going to paste in a testnet token that I created already, and I've done the same with the wrapped Bitcoin. That is out of scope of this video. If you are looking to create a native fungible token, you can do it in many different ways. I'll drop a link to some videos below as well, just so you can check it out if you are interested in that. But we're assuming you know how to create your own token here. And then the metadata string, this is just a generic metadata string of a NFT collection on the Hedera network. I'm going to click on transact. This is now going to deploy the smart contract. Obviously, I need to pay the very small fee. Great, now the smart contract's been deployed, and the first thing that we need to do before interacting with any of these purchase functions is we need to actually create the NFT. But before I do that, I just want to quickly call some of these get latest HBAR price and get latest Bitcoin price functions, and we're going to be able to see what sort of result it comes back with. So as I mentioned, it comes back with an 8 decimal number, meaning there's going to be 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8, before it comes to the price of Bitcoin. So here it's saying Bitcoin is 96,679. Likewise with HBAR, if we get the latest HBAR price, it will come back with a smaller number because 1 HBAR is much less than 1 Bitcoin. And actually all of these are the 8 decimals, and this HBAR price is 26 cents right now. So let's now create our NFT. I'm just going to create a very generic NFT. Also for this we need to send a bit of HBAR, only about 4 HBAR, maybe a bit more just to make sure. No, 4 should be, let's do 5. We need to give it a bit of HBAR because the creation of a non-fungible native token costs HBAR. So let's transact that. And just a quick detour. So we can see that we've created this NFT. We called that function. We have a look on the Block Explorer. If you've configured your MetaMask so that you can have the HashScan link as your Block Explorer, when you click on View on Block Explorer, it will automatically open on HashScan. And we can see that we've got a token created over here. Amazing. So now that we have actually created our non-fungible token, we can now start buying it. Because we are going to be using a Hedera token service token, and we're going to be calling the wrapped Bitcoin transfer from function, we actually need to do something before we can trigger this function here. The first thing that we need to do is we need to approve the allowance of the wrapped Bitcoin so that the smart contract can spend it on our behalf. If I try to call it now, purchase with Bitcoin, we would hope that this fails. And the reason why it would fail is because we haven't yet given the smart contract the approval. So I'm going to just go what happens when it fails, and we'll see that it's because the spender does not have the allowance, the spender being the smart contract in this case. But obviously in order to get around approving it, we need to just approve it. So I'm going to do that in my Hashpack wallet. MetaMask unfortunately doesn't have the functionality out of the box to approve a native Hedera token on MetaMask. So I'm going to have to do it on my Hashpack wallet. Let me sign in. And I've just signed into my Hashpack, but I see that we've got this fail over there. And the reason why it's failed, again, if we have a look on the block explorer, it's because this spender does not have allowance on the crypto transfer. I'm going to approve the allowance on my Hashpack application, and then I'll get back to the video. Amazing. So inside of my Hashpack wallet, I've just approved the smart contract to be able to spend this amount of Bitcoin, which is 10,343 divided by 10 to the power of 8. So now if I call this purchase with Bitcoin function, we're hoping that there's a green tick over here, because now that the smart contract has the ability to transfer out of that account, which I've just given the approval allowance for, it should be able to execute this function without any issues. And as we can see, we have this green tick, meaning the smart contract is executed successfully. And if we go over to the block explorer and we have a deep dive on actually what's happened, we'll be able to see that, okay, we've transferred the crypto, we've minted the token, and then we've transferred the NFT to the new user, and we can see all of the cool traces over here. So this first function, this is performing the transfer transaction. Looks like the first thing that's happened, yeah, so we've got this, I think this is doing the Bitcoin transfer. Then we're calling the latest round data, so this is coming from the Chainlink Oracle, and we've got the answer over here, that's our Bitcoin price. Then we have our transfer from function, so it looks like this is doing, right, yeah, this is actually transferring the Bitcoin, this is transferring the wrapped Bitcoin from the user to the smart contract, the same amount which we had over here. And then also we can see further on if we want to see the other functions like transferring the NFT, minting the token, and then transferring the non-fungible token to the user as well. So that's really all I wanted to go through, guys. Have a look at the data, have a look at the data feeds from Chainlink, and really excited to see what you can all build. Thanks a lot for watching. Have a great day.